Welcome to College Matriculation of Engineering Kedah, a center of knowledge and discovery.
Greetings, students of College Matrikulasi Kejuruteraan Kedah. Today, let's explore simple harmonic motion, or SHM.
SHM is motion back and forth around a central position, with a restoring force opposite to displacement.
Sometimes when we examine the motion of an object, it will involve a single action, like a rock falling from a cliff down to the ground. This will probably just happen one time, after which the rock will remain at rest. But some motion is periodic, meaning repeated, like the motion of the pendulum on a grandfather clock, or the vibration of a spring.
Initially, the mass is at rest or in the equilibrium position. It is because of two equal and opposite forces. The tension T in the string is equal to the weight W of the ball. Hence, mass is present at mean or equilibrium position. Now let the length of the string is L. I displace the mass from the mean position to the extreme position. The arc length from the mean to the extreme position is S. Let the angle at which I displace the mass from the mean position to the extreme position is theta. And the direction of theta is like this. Remember that theta should be small and it must not be greater than 10 degrees. It is because if you increase the value of theta, the pendulum will not perform SHM perfectly. Now again, two forces act on the mass at the extreme position. The tension T in the string pulls the mass in upward direction, while the weight of the mass pushes it in the downward direction. Here, note it down that the direction of the weight on the mass is like this, not like this, which is the common mistake of many students. Although both the tensions and weight act on the mass at the same time, but this time mass doesn't stay at the extreme position. Rather, it accelerates towards the mean position.
So after we open the website, we can see a lot of buttons here, which is include the home button, 3D simulation, theory, data and graph, and submit the report, and about us. Other than that, here also got a lot of extra features just like achievement and goals, so we can see how about our progression right now. And also, if we don't like the background color, we also can change this in the button of the customized background. And here also got a physics calculator, which is include the basic calculator, gravity calculator, and the arrow calculator. And other than that, we also got the day mode and night mode. And also got the AI chatbot. So if you got any question want to ask, we can just ask in the chatbot. So after that, I will explain the page of theory. So the page of theory here will include the objective for this experiment and also got the key formulas. Other than that, here also got show the procedure that how should we do the experiment, and also got show the source of errors, and also got show the gravity calculator. Other than that, here also got show the key conclusion at the last. Here also got show the error calculators.
After the theory section, we have the 3D simulation, which is the interactive pendulum system. It's where all the students can collect the data. Okay, so when you go to the website, we have the control from the length to the initial angle and the mass. So we can including the change from the length from 1 meter to 2.2 meter. At the same time, we have the initial angle from 15 degrees or even 5 degrees if you want to, and the maximum is 45 degrees. It's up to you, the student, how you're going to release the pendulum. At the same time, we have the mass from 1 kilogram to 5 kilogram. So after that, we start the simulation. Let's see, we start. Okay, we start. So it already gives the notification. After it starts, we can collect the data. So it will say the notification gives the data and we can stop it. So after that, this data, we go to the section called data and graph. So where you can see the length of it and also the plotting of the period of the length. We have two graphs as well, period versus length and also t squared versus length. So this is how